All right, welcome to video 2 for lesson 22, our last lesson. All right, in this problem, we're asked to find the area between these two curves, y equals 6 minus x squared and y is equal to 3 minus 2x. And we were not given any x values. We're not told it's from x is equal to something to x is equal to something else. Let's make a quick picture of this. Make a sketch. We're making a sketch so we can tell which function is the top function, which function is the bottom function, and maybe get a little bit of insight into where the bounds of integration are. I'm a little bit worried about making this picture without knowing where these functions cross. So I'm going to do that kind of at the same time. Check for intersections. So the color coding process, I'm going to use blue for the first one. Parabola 6 minus x squared. And I use red for the second one, 3 minus 2x. To check for intersections means I'm going to set y equal to y. So 6 minus x squared equals 3 minus 2x. And then solve for x. See what x values make this true. So I'm going to move everything over to the right. We get x squared minus 2x minus 3 equals 0. So subtracting 6 from both sides and subtracting negative x squared from both sides. Okay, this is a quadratic. I'm going to solve it by factoring. I want numbers that multiply together to give me negative 3, add together to give me negative 2. And the answer is negative 3 and positive 1. That means we have two x values, two solutions. X is equal to positive 3. Make the first bracket 0. And x is equal to negative 1. We'll make the second bracket 0. So they're both solutions. Okay, so I'm going to use that information in two different ways. One way is the sketch. So we're going from negative 1 to positive 3. Now, and then our y values. Let's see, if I plug in 3, I get negative 3, negative 3. If I plug in negative 1, I get 5. So we have to go from at least negative 3 to 5. Do one more. Okay. So now the blue curve, 6 minus x squared. It's a parabola facing down. When x is 0, the y value is 6. And then it's opening down. Let's see. When x is negative 1, we're going to get the value of 5. When 1, we're going to get 5 as well. Not be too picky about this. There's the shape. There's the shape. And then y equals 3 minus 2x. So intercept of positive 3 and a negative slope. So it'll be something like that. I know it's not perfect. I didn't draw it right. It's showing that it's crossing at 2. It's really supposed to cross at 3, but it doesn't matter. This is not for art. This is not for a pretty picture. It's just a sketch to help us identify what is the top function, what is the bottom function, and what are we integrating from what to what. Okay, step 3. Set up and solve area integral. So the area is the integral from a to b of the top function minus the bottom function. So we're integrating from -1 to 3. Our top function is the blue one, 6 minus x squared. And our bottom function is the red one, 3 minus 2x. Okay, before integrating, we have to simplify. Let's collect like terms. 6 minus 3, we get 3. And then nothing else combines, negative x squared minus minus, so plus 2x. Now we will integrate this. Take the antiderivative. The antiderivative of 3 is 3x. Antiderivative of x squared is 1 over 3x cubed. And then the antiderivative of 2x is x squared. And then we'll evaluate this from -1 to 3. This is where I make all my mistakes. There's a fraction in there, and I'm gonna make an error. Let's see how far it takes before the error comes in. So 3 times 3, we get 9. 1/3 of 3 to the 3, so 1/3 of 27. We get 9. And then plus x squared, we also get 9. And then subtract the bottom bound. So 3 times -1, we get -3. And then -1 to the 3 times -1/3, we get positive 1/3. And then -1 squared is just 1. Let's add up all the whole numbers. We have 9 minus 9, those cancel. And then 9 minus -3 plus 1, so 9 minus -2, we'll get 11 minus 1/3. Make the common denominators 33 over 3 minus 1 over 3. We get a final answer of 32 over 3, and I have no idea if that's right. You check. You let me know if it's wrong. If I made a mistake somewhere. Probably in this subtracting. Now what will never happen? If you put this together properly, you will always get a positive answer. If you ever get a negative answer when you're constructing an area integral, so when you're building it as top function minus bottom function, evaluated from a to b, and if you do it correctly, you'll always get a positive. Getting a negative out means you either constructed it incorrectly, or you integrated it incorrectly, or you evaluated it incorrectly. Okay, next example. Find the area that's bounded by sine of x, cosine of x is equal to 0, and x is equal to pi over 2. So let's see what that looks like. So step 1, I'm going to make a sketch. And step 2, check intersections. Right, so the sketch, I know I don't need any negative x values since I'm going from x is 0 to x is equal to pi over 2. And that's first quadrant, so I don't need any negative y values either. Sine of x and cosine of x are positive, so that helps me identify where my sketch goes. I also know that the y value can't be larger than 1 since sine of x and cosine of x both have a range that goes from -1 to 1. Just indicate pi over 2 over there on the far end. I can make a picture of sine and a picture of cosine, but let's check for intersections first. So when we check for intersections, we have sine of x is equal to cosine of x. Divide both sides by cosine of x. So sine of x over cosine of x is equal to 1. And we get tan of x is equal to 1, which has only one solution between 0 and pi over 2. It's pi over 4. So it's worth commenting here. The only solution from x equals 0 to x is equal to pi over 2. That's what we're integrating from. So we have to indicate that special x value. Something's going to happen there. They're going to cross. Now let's do our sketch. Sine of 0 is 0. Sine of pi over 2 is 1. And the shape is going to look like this. It's going to keep going on this side. It's going to keep going on this side, but those pieces are not important for the problem. Now for cosine, cos of 0 is 1. Cos of pi over 2 is 0. So it's going to have the opposite shape. Okay, and we want the area going from 0 to pi over 2 that's bounded by those two curves. So here's my line x is equal to 0. Here's my line x is equal to pi over 2. And notice what has happened here. We have two different areas. I'm going to call the first one area 1, call the second one area 2. So this is new. This hasn't happened to us yet. We haven't had to do this type of a problem until this example. So step 3, create area integral. And I put an S on the end of that word because it's plural. There's two integrals we're going to need. An integral for area 1, integral for area 2. So we're going to have an integral from A to B of top minus bottom plus an integral from B to C of top minus bottom, where the top and bottom in each expression could be different. So we're integrating from 0 to pi over 4 for the first function, or for the first region. And the top in the first is the red one, cos of x, minus the bottom in the first is sine of x. Now we're going from pi over 4 to pi over 2 of top minus bottom. So on the right, in the second area, the top is the blue one, sine of x minus cosine of x. Okay, that's it for setting up the integral. Next, let's take the antiderivatives. Antiderivative of cosine of x is positive sine of x. Antiderivative of negative sine of x is positive cosine of x. That's evaluated from 0 to pi over 4. Plus, antiderivative of sine of x is negative cos. Antiderivative of cos is sine, so we get negative sine of x. And that's evaluated from pi over 4 to pi over 2. Okay, let's plug in the top bound. Sine of pi over 4 is 1 over root 2. Cos of pi over 4 is 1 over root 2. Now plug in the bottom bound. Sine of 0 is 0. Cos of 0 is 1. Now the next two, plug in pi over 2, we get negative cos of pi over 2, which is 0, and negative sine of pi over 2, which is negative 1. Then add in the bottom bound, or subtract the bottom bound rather. So I have negative 1 over root 2 minus 1 over root 2. And then simplify. I have to go up here to finish this off. So we have 1 over root 2 plus 1 over root 2, that's 2 over root 2 minus 1. And then for the next piece we have another minus 1. And we have minus minus plus 2 over root 2. So that's going to be, well, 2 over root 2 is just root 2 minus 2 plus root 2. So what happened there is 2, well, I'll use a different color. I haven't used yet. I haven't used purple. Okay. 2 over root 2 is equal to root 2 times root 2 over root 2. You can cancel and get root 2. So that's what's going on from there to there. Those two pieces. Now we have a root 2 plus a root 2, so that's 2 root 2 minus 2. That's our final answer. If you want to, you can common factor 2 out. You have 2 times root 2 minus 1, and root 2 is larger than 1. It's 1.4, so we do get a positive quantity here. Also, a neat thing is, if our picture was better than this, if you had a really high quality picture, you could tell that the area from 0 to pi over 4 is the same as the area from pi over 4 to pi over 2. So a shortcut would be to find the integral from 0 to pi over 4 of cos of x minus sine of x, that's the area for the first region, and just double it, multiply it by 2. And if you look carefully what we have here, that's exactly what you would find. Neat, eh? Alright, next one. Find the area of the region bounded by y equals x minus 1 and y squared equals 2x plus 6. This isn't nice. This is bad. Because this doesn't follow the template that we've had so far. All the problems we've had previously were problems where we could write y is a function of x. But now, we can't do that. We can't write y as a function of x. It looks like we could, however, write x as a function of y. So this is what the picture looks like. Y squared equals 2x plus 6. Y is equal to x minus 1. We're looking for the area that's contained. And there is, like if you look at this graph, there's a way you could do it. Definitely. You could split it like this. Split it at that value indicated by C. To the left of that value, your top function is y equals the positive square root of 2x plus 6, and your bottom function is y equals the negative square root of 2x plus 6. On the right hand side, your top function is the positive square root of 2x plus 6, and your bottom function is x minus 1. Definitely would work. You wouldn't have any error if you constructed it that way. But I don't want to do that. It's too much work. I'll show you an easier way. It's kind of it's more than a shortcut. It's a different construction altogether. Imagine instead if we used rectangles that were turned sideways. So the width was not delta x, but was instead delta y. Now the height of the rectangle would not be given by a difference in y values, it would be given by a difference of x values. So if you go through the construction, instead of being the integral from a to b of the top curve minus the bottom curve, it turns into the integral from c to d if you want, you can use A and B again, doesn't matter what labels are used, they're arbitrary, of the right curve minus the left curve. So the curve with the higher x value minus the curve with the lower x value, as long as you're rearranging these to be read as x in terms of y. So this is called sideways integration, where you're integrating with respect to y. It's weird, but it works. And it shouldn't bug you that much. I'll tell you why it shouldn't bug you. Math does not care about our piddly alphabet. It never has and it never will. For example, if we have a function, f of x equals x to the power of 3. We take the derivative, df by dx, we get 3x squared. What about another function? What if I said f of t is equal to t to the 3? We take the derivative, df by dt is equal to 3t squared. Let's do another one. F of, well, we'll do the smiley face. F of smiley face is smiley face to the power of 3. So df by d smiley face is 3 smiley face squared. I'll do one more. F of y is y to the 3. So df by dy is 3y squared. The rules of calculus do not depend on the letters of the alphabet that are used for the variable, or for the function for that matter. I called them all f, but I could have called them all something different as well. I could have also used a pizza slice or a poker face or z. Doesn't make any difference. So if you think about what that means for this problem here, you could sing the alphabet song backwards just at the end. So instead of x, y, z, you could sing x. Well, let's just, I want to swap the x and the y in the alphabet song. So not quite the end, but almost at the end. I want to swap those two in the alphabet song, and that's it. So imagine if those letters were just interchanged. So our expression is x squared is equal to 2y plus 6, and x is equal to y minus 1, and we rearranged both of them to write y in terms of x. We would get the exact same answer, and that's one way to approach these. So we can swap all the x's with y's and all the y's with x's simultaneously. Nothing will change because the letters are arbitrary. It helps with us, though. It helps with our own problem-solving process because we're used to writing y in terms of x. That's just what our habit is. So this is a step that's done to take advantage of the habits that we've already constructed for solving problems. So the first function here, x is equal to y minus 1. If we add 1 to both sides, we get y is equal to x plus 1. And the second function, take a little bit more work. So I'll do this one in 2 steps. 2y is equal to x squared minus 6. Then divide both sides by 2, so y is 1/2 x squared minus 3. So those are our 2 functions. We still have to make a sketch. Step 2, check for intersections. So the checking for intersections, I'll do that part first. X plus 1. I'll keep numbering it step 1, step 2, and I always do step 2 first, but I really want to reinforce that the picture is important. You have to do it. Okay, next step. I'm going to multiply both sides by 2 to get rid of the fraction. So 2x plus 2 is equal to x squared minus 6. So everything on both sides has been multiplied by 2 to get rid of that fraction. Now I'm going to subtract 2x from both sides, subtract 2 from both sides. So 0 is equal to x squared minus 2x minus 8. Factor. This is x minus 4 times x plus 2. And we get two solutions. X is 4 and x is negative 2. And that will give us our bounds of integration. Now for the sketch. We know that they are going to cross at negative 2 and positive 4. Our curve y equals x plus 1, straight line, intercept 1. And then the curve 1/2 x squared minus 3 has an intercept of negative 3. And it's a parabola facing up, so it does something like this. And notice I didn't draw it right. I'm not going to go back and erase it. It's supposed to cross at an x value of 4, but it's not. It's looking like it's crossing an x value of 3, and it's just because this is a sketch. I just want to know. It needs to be good enough to tell which is the top function and which is the bottom function. Okay, step 3. Construct the area integral. We only need one integral this time. There's only one region. So the area will be the integral from a to b of the top minus the bottom. So integral from negative 2 to positive 4, the lower x value to the higher x value. The top curve is the purple one, the higher y value inside the region of interest. So x plus 1. Minus the bottom curve is 1/2 x squared minus 3. Okay, then we can clean this up a little bit. Combine like terms. X doesn't combine with anything, it's on its own. We have 1 minus 3, so 1 plus 3, we have 4. And then minus 1/2 x to the power of 2. Nothing combines with that either. Okay, now we can take the antiderivative using the anti-power rule. And I did not pick very good numbers for this, did I? It's okay. So we get 1/2 x squared plus 4x minus 1/6 x to the power of 3. So the power goes up by 1, and we have 1/3 times that, and 1/2 times 1/3 gives you 1/6. And we're going to evaluate this from negative 2 to positive 4. Alright, so let's see what happens when we plug 4 in. 1/2 of 16, so 8, plus 4 times 4 is 16, minus, that's that 64 divided by 6. Okay, and then minus the evaluation at the bottom bound. So we have 1/2 times positive 4, so 2. And then minus 8, and then minus, so plus 8/6. Okay, then collect all the pieces together. We have, let's see, I'll do it in steps. 24 minus 64 over 6, and then we have plus 6 minus 8 over 6. So 30 minus 72 over 6, which is 30 minus 12, which is 18. Hopefully that's right. Hopefully there's no errors that are made. Please email me if there's a mistake and I'll correct it in the notes. I'll make a comment beside the video as well. Oh, okay. It's good. I have it typed up here. I'll leave the typed up one and then, yeah. Okay. Makes me happy. Next one. Same idea. We have x is equal to y squared, x is equal to y plus 2. And I'm going to do this one two different ways, actually. I'm going to use two different methods. Because not everyone, not all math profs like the way that I do these problems. Some look at the way I do the problems and say, what are you doing? How come you switch all the x's and y's? You're robbing the students of the ability to think sideways. Okay, well, I'm not going to force you to think sideways, but I'll show you what thinking sideways looks like. Step 1, sketch. We're going to have to sketch sideways. Step 2, intersections. I should preface this by calling it method 1. The bad method. Won't let anyone tell me differently. This is the bad method. It treats the alphabet as if it's sacred, and it's not. So in the bad method, we have, for intersections, we're going to set x equal to x instead of y equal to y. So y squared is equal to y plus 2. Subtract y from both sides, subtract 2 from both sides. Factor. This is y minus 2 times y plus 1 is equal to 0. And we get two solutions, y equals 2 and y equals negative 1. Okay, so for the sketch, those are our important y values. See, I'm not even sure how to sketch this sideways. Let's see how it goes. The x-axis and the y-axis are still in the same spots. Okay. The line or the curve x equals y squared is a parabola going sideways. If y is 0, x is 0. If y is 1, x is 1. If y is negative 1, x is positive 1. It hurts. Doesn't it hurt? Is your mind like hurting right now that you have to graph sideways? Okay, now let's do the line. X is equal to y plus 2, but I'm not going to rearrange it. I'm not going to write it as y equals mx plus b. I'm going to leave it as x is equal to y plus 2. So let's see. When we're going to plug in a value for y and get the corresponding value of x. If y is 0, x is 2. So y is 0, x is 2. We're over here. And then if y is 1, so go up, x is going to be 3. So we'll have something like that. Okay, so we're looking at this region here. Now keep in mind that when we set up the integral, we're going from the lower y value to the higher y value. If we want to think sideways, we're going from -1 up to +2. That y value there where they cross. So part 3, construct and solve area integral. So the area is the integral from the lower y value to the higher y value, from -1 to 2, of right minus left. Now we're integrating in the y direction. So -1 to 2. The rightmost function is the green one, the one with the higher x value. The green one is the line y plus 2. And then the leftmost function is the blue one, which is y squared. Yeah. And we're integrating with respect to y. Okay, antiderivative of y is 1/2 y squared. Antiderivative of 2 is 2y. Antiderivative of y squared is 1/3 y to the 3. And then we're evaluating this from -1 to 2. Okay, plugging in the top bound, we get 4/2, so 2 plus 4 minus 8/3 minus the bottom bound, we get 1/2 minus 2 plus 1/3. And then collect like terms, or everything's like term, I guess. 2, 4, 6, and then 6 minus 8/3, and then the other piece we have minus 1/2 plus 2 minus 1/3. So 6 plus 2, 8, and then we have 8/3, -8/3 minus 1/3 is -9/3, which is 3. So 8 minus 3, 5, minus 1/2, which is 10/2 minus 1/2, we get 9/2 as our answer. Here's some more. No, okay, 9/2. I just hope that one's right. Okay, next method, method 2. The better method. The far superior approach is to say, hold on, this is a sideways problem. I don't like sideways problems. I'm going to swap x's and y's everywhere. So the first function we have is not x is equal to y squared, it's y is equal to x squared. And the second function is not x is equal to y plus 2, it's y is equal to x plus 2. We are not just rearranging these equations. We're not solving for x, we're not solving for y. We're swapping all the x's with all the y's and all the components. Now we're going to solve it like we would without going sideways. We're going to sketch. We're going to find the intersections. And as you go through this, you're going to see how little it matters what we call x and what we call y. So here for the intersections, if we're going regular, we're going to set y equal to y. So x squared is equal to x plus 2. Look what we had on the left-hand side. Y squared is equal to y plus 2. Let's keep going. X squared minus x minus 2 is equal to 0. Everything's going to be the same. X minus 2 times x plus 1 is equal to 0. So we get two solutions. X is equal to 2, x is equal to negative 1. Okay, and then the sketch. I mean, you don't even have to think to make this sketch. Y equals x squared is a parabola facing up. And y equals x plus 2 is a line with intercept 2 and slope 1. So it's this type of a shape. Now we're looking for this area. And even with this super like sketchy sketch, you can see that the areas are going to be the same. Like nothing's changing when we change the letters of the alphabet. So area is equal to integral from negative 1 to 2 of the top function minus the bottom function. And now we're integrating with respect to x instead of integrating with respect to y. Integral from negative 1 to 2 of the top function is x plus 2 minus the bottom function is y squared. Integrating with respect to x. We get 1/2 x squared plus 2x minus 1 over 3. Oh, why did I have a y there? Oh, because I'm copying. I'm not thinking. X to the 3. Evaluated from negative 1 to 2. And we're going to get all the same stuff. It's all the same. We're going to get 9 over 2. Unless I made a mistake in the arithmetic. So, the take-home message is when you are facing an area problem where it appears that you will need to integrate in the y direction, if you don't want to hurt your brain, if you don't want to be graphing things sideways, making a sideways sketch, and then thinking about area being constructed as going from a lower y value to a higher y value of a right curve minus a left curve, if you want to keep everything simple, swap all your x's and all your y's, and there you go. That's all you have to do. Okay, next problem type. Find the area between y equals e to the x and y equals x between x is equal to 1 and x is equal to 2. So step 1, sketch. Step 2, intersections. So for intersections, we have y equals y, which means e to the x equals x. And this is a big question mark. Like, how do you do this? How do you solve? And the answer is you can't. So I'm going to make a sketch and see what does that mean. Now you might be tempted to take the log of both sides. Then you have x equals ln x. Now you're stuck in a different way. There's nothing good you can do here. What does the sketch show? Okay, e to the x looks like this. When x is 0, the y value is 1. It's not very even, is it? At least make a mild effort to do that properly. Okay. When x is 1, the y value is e. So that's 1, that's 2, that's 3, so it's a little bit below there. So let's say 2.7. Next it's 2, e to the 2, so 2.7 times 2.7, it's up here. So it's going to have this type of a shape. Don't do that. Doesn't have to be perfect. And then the line y equals x. when x is 0, y is 0. When x is 1, y is 1. X is 2, y is 2. And then you can tell these are never going to cross. Okay, we're going from x is equal to 1 to x is equal to 2. So we're looking at this area here. So don't be thrown off if you can't find the intersection points. There may not be any. Okay, step 3, construct area integral and solve it. So the area is the integral from 1 to 2 of the top curve minus the bottom curve. So the top curve here is the blue one, e to the x. And the bottom curve is the red one, which is x. And we're integrating in the x direction. Okay, antiderivative of e to the x is e to the x. Antiderivative of x is 1/2 x squared using the anti-power rule. And we're evaluating this from 1 to 2. Now plug in the top bound, e squared minus 1/2 of 2 squared, so 1/2 of 4, which is 2, minus, plug in the bottom bound, e minus 1/2. And we don't get a very satisfying answer, and that's okay. It doesn't always give you a nice result. E squared minus 2 minus e plus 1/2, which simplifies after making common denominators. So negative 2 is the same thing as negative 4 over 2. So we have negative 4 over 2 plus 1 over 2, which is negative 3 over 2. E squared minus e minus 3 over 2. Oh. Circle too much. There we go. Next one. Let's see. How many more do we have? Oh, a whole bunch. Okay. All right.